Alright, today we are starting inverses and their functions. Very first thing I want you to do is we're going to look at the horizontal line test. And right now we have a function right here. This function is just called y equals f of x. Alright, it kind of looks like an exponential function. We don't know the exact equation, but this blue curve going up is a function. And in words, basically, if a function f, which is this, has an inverse function, which is f to the negative 1, and if only each horizontal line intersects the graph at one point. So if and only if each horizontal line intersects the graph at one point, then this function will have an inverse that's also a function. So right now, this right here intersects this graph only one time. So therefore, whatever this graph is, it will have an inverse that's also a function. Let me show you something that's not a function. Like its inverse isn't a function. So I'm going to go right here, y equals x squared. Y equals x squared. I'm going to hit graph. We'll take a look at it. Now, does y equals x squared, does this pass the horizontal line test? No, it does not. Okay? How many places does this cross? Crosses twice. So y equals x squared, all right, its inverse is not a function. Now if you wanted to know what it would look like, it's kind of a cool feature. Now we're gonna end up solving these, okay? But before we learn how to solve them, I'm gonna show you a cool feature of the calculator. What I want you to do is go right here to second mode. We're going to hit second program, go down to number 8. We're going to draw the inverse of our function. Well, where is our function located? It's located in y1. So you have to hit alpha, trace, enter. And watch, this will draw the inverse of this. So right now, this right here is the inverse of this function called y equals x squared. So is this inverse a function? Does it pass the vertical line test? No. So the inverse of this function, if drawn correctly, it does have an inverse. The inverse just happens not to be a function. Now, all functions and their inverses actually reflect over what's called y equals x. You can see how everything is perfectly reflected across y equals x. So let's split that perfectly right down the middle. You see the line, this is a line of symmetry. So all functions and their inverses, what do they reflect across? They reflect across y equals x. So any point that you have, if you have an x and a y, if you have any point, we'll just call it a and b, the inverse of the function will always be b comma a. So let's test it right here. Let's look at something. Right here, what's this point right here? What's that point? That's at a 4, negative 2. 4, negative 2. So what should we have? We should have a what? Negative 2 and a 4. Do we have a negative 2 and a 4? We do right there. These are perfectly across from each other. The way you can tell is if I connect these, if I make a line from here to here, what type of angle is created with this line of symmetry? What type of angle? A right angle. Okay? If you don't believe me, I can put a protractor right here and rotate it. I know. What? If they started watching the video right here, it's like, what the heck is going on? Okay? So, does everybody see the right angle that's formed? That's if you go what? Across your line of symmetry. Every single point, if you connect it, should make a what? A right angle with this line of symmetry known as y equals x. So what I want us to do right now, I know that's a lot going on. I'm going to hit y equals, I'm going to clear this out. clear this out. Okay? And what I want us to do is I want us to type in problem number 2. Just type in problem number 2 in your calculator. See how it works. Okay? So we're going to get negative second x squared, gets that radical, x plus 3, right arrow, minus a 1. You hit the graph button, you take a look at it, and there is your function. Okay? So what does this function right here represent? This represents y equals negative radical x plus 3, and then we have a minus 1. Does this pass the horizontal line test? It does. So this does pass the horizontal line test, which means its inverse is a what? Its inverse, now I didn't ask you to find it yet, we'll do that tomorrow, but this inverse is a function. Does it matter where you put the horizontal line? No, as long as you do what? As long as you make it cross the graph and it only crosses once. So here's what we're going to do. Go to y equals. Go down here to y2, hit x, hit graph, and I want you to understand the inverse should reflect across that. So we're going to try to remember the steps to get to it. Ready? Hit second mode. By the way, here's the cool thing. If you've already done it once, you can scroll up and grab it again. But you know what? Let's say I didn't want to do that. Let's say I want to go over the exact steps one more time. Here's what you do. Second, program. Number 8, alpha, trace, enter. I'm going to write those steps down now, okay? Whoa. So the steps to get draw inverse is you hit the second button, then you hit the program button, then you hit the number 8. Now I'm going to highlight that. So just in case people who aren't here today need to watch the video, they know how to do it. So second program number 8 gets you the what? That gets you the draw inverse part. Okay. Next part. Alpha. And trace. And what does the alpha then trace button give us? That gives us the y1. Okay? Now the cool thing is when you do that, now it doesn't give you the formula, but when you do that, you get to see what the inverse would look like if you solve it correctly. I don't know about y'all, but I think it's pretty cool. I did not have this function on my calculator back in high school, just to let you know. Alright? You can do everything by hand. You can walk 3 miles to school backwards in the snow. Just kidding. But right here, see how they're perfectly symmetrical across y equals x. Alright? So right now, this point right here, what's this point at? Yep, negative 3, 1. Alright, 1, negative 3. Look, there's the inverse of it, right? 1, negative 3. This is the pattern you need to look for when you're doing this, okay? So what I want you guys to do, graph the first 4, and what do I want you guys to apply to it? Apply the what? Horizontal line test. So right here, horizontal line. Horizontal line. Horizontal line, you can put it wherever you want. Just don't put it down here, okay? That would be bad. Put it through the grid. How many places does it touch? On the first one. 2. Uh-oh, if it touches more than once, I'll let you know the inverse is not functional. It does have an inverse, it's just not a function. Okay? This one, yes, it does have a function. Yes, this one is a functional relationship, and yes, this one will have an inverse that is also a function. So that's what you're doing on the first 4. So what I want you guys to do is make sure you have, go back here, make sure you have this in your journal, all right? Write it down nice and neat, word for word, graph and all. That's what your job is today. That's a short video.